So today we will discuss some programming examples which are based on stacks, queues, and linked list data structure. This is your first program which is based on stack data structure. If you see this program, what we have done, we have created a class called myStack. And inside this class, we have created a variable called maxSize, which is integer data type variable, and it is private. Then we have a stack array variable, which is of type long, and again private variable. And then another variable called top. Okay, because if you remember, in case of a stack, why private variable? Because if we want to create a class, okay, inside this class called myStack, okay, so we don't want these variables to be used by that class because these variables are private to myStack only. Because if you remember, in case of myStack, what we have a top variable through which the elements can be inserted and deleted. That means they can be pushed and popped. So we want these variables to be private to this class only. That's why. Okay? Now you see, we have a function called myStack, and here we have a maximum size is equals to s, means whatever the number of elements you will enter inside a stack, the size of a stack will be equals to s. That means if suppose you enter 4 elements, so the maximum size will be 4. Okay. And then we have a push method through which we will push the data elements. I don't see anything. Yes, there is a slide. You can't see, Miss Fatima? Miss Amal, can you see this slide? Is it visible to you? Yes. Miss Fatima, this slide is visible to you? Okay. So here we have a push method through which we will push each and every data element, and every time the data is inserted into a stack, top is incremented. That's why we have plus plus top. Okay, top is incremented. And then when we perform pop operation, top will be decremented. Okay, top will be decremented. And then we have a peak function. Okay. Okay, connection problem. No issue. Now we have a peak function through which we can reach at the top without deleting the elements of a stack. That's why return stack array top. And then there's another function called isEmpty. It is Boolean in nature. Boolean because there will be just 2 values for this function, either true or false. So if the stack is empty, it will return top is equals to -1. If top is equals to -1, it means that the stack is empty. So it will return true or false. And then it will check whether the stack is full or not. If it is full, then it will return top is equals to max size -1. Whatever the size of a stack, suppose it is 10, okay? So 10 minus 1 will be 9, because the elements will start from 0, okay? 0, 1, 2, 3, like this. Like in case of array, if you want to specify the size of an array, you want to enter 10 elements, okay? So the index value will be from 0 to 9, 1 less than the size of array. That's why max size -1. Now next is our main method, And inside this main method, first of all, we have created the instance variable called dStack. This is the instance variable, okay? And then this instance variable is used to push these values inside the stack, okay? dStack dot push 10, likewise up to 50. And then we will check whether the stack is empty or not. If while stack is empty, and here we have not, so the logical operation is not. So while not, the stack is empty, what will happen? We will pop the values until and unless the stack is empty. We will pop out these values, whatever we have entered, and then we will print these values. Okay. Now, can you tell me what will be the output of this program? Remember that stack is last in first out data structure. Can you tell me what will be the output of this program? $150? How $150? How $150? Means you have added these items, 10 plus 20 plus 30, like this, up to 50. That's why 150. Why you have added it? Why you have added? We have a stack, okay? We have a stack, okay? And we have inserted these values. First value is 10. First value is 10, okay? Second value is 20. Third value is 30, okay? Then we have 40. And then we have 50. Okay, now we have not performed any addition operation. We haven't performed any addition operation. Can you see any addition operation here? Any add operation? Or any or add operation over here? Is there any add operation? Is there any add operation? Boolean. Boolean means yes or no. Boolean does not mean addition. Okay. So there is no add operation. So it cannot be 150. Okay. It cannot be equal to 150 because we are not performing any addition operation. What we are performing? We are just popping out these values. Okay. The stack dot pop. We are popping out these values. We are taking out these values from a stack. And we are printing it. You can see. We are printing these values. This one. So what will be the output? First of all, which value will be popped? 10. How 10? 10 is the first element. This is stack data structure. Stack is last in, first out. Okay? Stack is last in, first out data structure. So in last in, first out data structure, which element will be removed first? 50, 40, 30, 20 and 10. Yes. Firstly, 50 will be deleted or removed, then 40, then 30, then 20 and then 10. And here we have space. Okay, we have space. So firstly we will print 50 and then there will be a space. Okay. Yes, start with 50. Yes, absolutely right. So start with 50 and then that value is printed. As you can see, system.out.print value, that value is printed. And after that system.out.print there is a space. So there will be a space after 50. And again, next element is 40. So 50, it will be like this, 50, then there will be a space. Then next is, yes, because LIFO. Then you have 40, and then you have 30, and then 20, and then again a space, and then 10. Okay, now let's see the output. This is the output. This is the output. Okay. So this is a simple program which shows you how to insert data elements inside the stack and how to remove those elements from the stack. So simple program which is based on stack data structure. Now let's see a program which is based on queue data structure. So here we have imported two packages, input output package and util package. And then we have a class called queue implement. Yes, this is based on FIFO. Okay, this is based on FIFO. First in and first out. Now we have these variables. Okay, linked list, string, str and integer number. Then we have main method inside which we have created an instance variable queue for the queue implement. And then we have a function called queue implement. Inside this function, if you will see, we have a try and catch block. Try and catch block. Can you tell me why we have included try and catch block? Try and catch block is included by, see, try and catch block are included to handle exceptions. Okay, because if you remember exception handling, we have used try and catch block in that. So it is used for exception handling. Now suppose if anyone has entered 0 or some illegal entry, then what will happen? Your program will terminate unconditionally. There will be an infinite loop or there will be no result at all. So we want to handle such situations where if a user has entered 0 or any null value or any illegal entry, then that exception must be handled by exception handling concept. So we have included try and catch block for that. Now what we have done, we will use input stream reader, okay, to read the inputs one by one. Okay, so firstly we will enter the number of elements and they are read by using buffer reader. Once those inputs are read, we will ask from the user to enter elements. Okay, if suppose user has entered 0, then it will be catched. Okay, this is an exception handling and it will be catched. Now we ask from the user to enter elements, and for I is equals to 0, I is less than num. What is num? Num is the number of elements that you have entered here. Number of elements. Suppose user enters 5. So next is enter these 5 elements. So suppose user enters 1, 2, 3, 4 and 5. So it should be total 5 elements. Total 5 elements should be entered because initially the user has mentioned that he wants to enter 5 data values. So it is 0, I is equals to 0, so it will be less than num, because if we start from 0, see, suppose the index value of this is 0, so it will be 0, 1, 2, 3, and this is 4. And 4 is less than 5, isn't it? This is num. This is num. 4 is less than 5. So it is less than num. And then I plus plus. We will read those inputs and then we will add it. Now next, if you see, yes, 0 to 4 is equals to 5. Total 5 values. Then we will print first element, last element, okay? And once these elements are read, it is removed from the list. It is removed from the list. And then we print rest of the elements in the list. Okay? Now can you tell me what will be the output of this program? First element. What about this? What about this? It comes first. System.out.println, enter number of elements. What about this? Okay, it will be first. So initially, what will be the output? First of all, what you will see on your output screen? Enter number of elements. Okay, good. Now, suppose user enters 4. Okay, suppose user enters 4. And after that, what will be shown on your output screen? First num. Where is first num written? Yes, enter number of elements. Okay, this is printed first. Okay, suppose user enters 1. Okay, no problem, 1. Then what will be printed on your screen? First element. Okay, what about this? What about this? System.out.println, enter elements. Okay, let me delete it so that it will be more clear to you. See, the user can enter anything. Here, it will be asked, enter number of elements. So user can enter 4, 5, 6, 7, 8, 9, 10, any value user wants, okay? Anything can be entered by the user, okay? Enter number of elements. So first of all, what is printed on your output screen? It will be printed, enter number of elements, okay? Now suppose user enters, yes, number will be chosen by user. Suppose user enters 6, okay? Now next question will be, what is this? See, this is statement, system.out.println, enter elements. So next question will be, enter elements, okay? Now since user has entered 6, so now he will be allowed to enter any 6 values he wants, okay? So any 6 values can be entered by him. Suppose user enters 10, then 20, then 30, then 40, 50, and 60. Okay, total how many values are there? 6 values, okay? How many values? 6, yes. This is first value, this is second, this is third, fourth, fifth, and sixth. Because initially user has entered 6 over here. If suppose user enters 10, then he can enter total 10 values. Okay? So it will be less than num. Because initially we are starting from 0. So the index of this number is 0. Okay? 1, 2, 3, 4, and this is 5. So 0 to 5, that means 6. And 5 is less than 6, num. So the user will enter 6 different values. Yes, 0 to 5. Total 6 values. Okay. Now next is system.out.println first element. First element. So what will be printed? It will be printed first element. Okay, first element. What is first element? 10. Yes, absolutely right, 10. Okay, once this is printed, it will be removed from the list. Okay, now next is last element. Last element. So what's the last element? 60. Yes, very good. This is 60. So it is 60 and plus list dot remove last. So once this is printed, yes, last element is 60. So once this is printed, it will be removed from the list because here you have list dot remove last. Okay. Now next is system.out.println rest elements in the list. So what is printed next? Okay, let me write it down here because there is no space. So next is rest elements in the list. What are the rest elements in the list? What are the rest elements? Now remember, this is first in, first out data structure. Okay, this is first in, first out data structure. So the elements will be removed in the order in which they were placed. So it will be 20, 30, 40, 50. Yes, absolutely right. 20, 30, 40, 50, because it is first in, first out data structure. Okay. So now let's see the output of this program. Let's delete it. Okay, now let's see the output. The output is enter number of elements. Suppose user enters 4. So next is enter elements. So you have to enter just 4 elements, because initially you have mentioned that you can enter just 4 elements. Okay. So the user has entered suppose 4, 9, 2 and 5. Then first element is 4. Last element is 5. Once they are printed, it is deleted from the list. And rest elements are 9 and 2. Is it clear? Why 9? Because here you can see first element is 4. Okay, it is printed and then it is removed from the list. What is the last element? 5. Okay, it is printed and then it is removed from the list. Now what are the remaining elements? What are the remaining elements? Nine and 2. Remaining elements are 9 and 2, isn't it? See? Here you have 9. This is 9. What are the remaining elements? Nine and 2, yes. So it is printed. And since this is first in, first out data structure, so firstly 9 will be printed and then 2 will be printed. Okay? First in and first out. Shall we move to next example? Okay. Now next example is based on linked list. Here we have created a linked list and we have inserted some data items in that linked list. So you can see over here, first of all, we have imported a package called util and we have created a class called linked list demo. And inside this linked list demo class, we have a main method. Now how we have created linked list? This is the statement. See this one? Linked list 2 is equals to new linked list. So 2, this is the instance variable for linked list. And then we have used this instance variable 2 to add some data items inside node. So what we have inserted F, B, D, E and C. And then what we have used 2.add last Z. So in the last we have added Z. This is the end of node. And then you see 2.add first A. So in the beginning we have added A and then 2 dot add 1 comma A2. Now 1 comma A2 means we will assign some index values to each and every node. Okay, so we start from 0. So 0 will be assigned to A because see, we have added F. Okay, this is our node. This is F. Okay, then what we have added? We have added B. Okay, we have B. Then next node, that is D. Then EC. Then we have E, and then we have C, and in the last we have added Z. Now next is 2 dot add last Z. Okay, Z is added. Then 2 dot add first A. So initially we have added A. Okay, so now this is our first node. Instead of F, A is our first node. Now index value 0 is assigned to this node. This is 1, this is 2, 3, 4, 5, and 6. And if you remember, in case of linked list, what we do, we have a pointer, and that pointer will point to next node. Okay, we have a pointer, and that pointer will point to next node. This is our linked list. Now we have 2 dot add 1 comma A2. Now what do you mean by 1 comma A2? It means that at index location 1, A2 is added. Okay, so now the pointer will point to another node, that is A2. Okay, so the position of this node will be 1, and now this node will point to F. So this will become 2, this will become 3, 4, 5, 6, and 7. Is it clear? Is it clear? No. Okay, what about Miss Fatima? Okay, it's clear to you. Okay, Miss Amal, see. When we have discussed about linked list, what we have seen that in case of linked list, we have nodes. Okay, and there are two portions in a node. One portion will hold the data, and second portion holds the pointer which points to the next node. You remember linked list? Okay, that's good. So here what we have added F, okay, to linked list. So what will happen? A node will be created, okay, and F is added to that node, and then this node will point to next node. Okay. Now what's the next node? Next node holds B. So here we have B, and then this node will point to another node. Okay. Now what's the next node? D. Okay, D, and so on. So we have CF, then B, then D, then E, and then C, and after that add last Z. So the last node will hold Z. Okay, as you can see over here, this is Z, last. Okay, and then we have add first A. So A will be added in the beginning. Now F is not first node. The first node will be A. Okay? First node is A. What's A2? Yes. Now you see here, A2 is the value, like A, F, B, D. It is a value. Okay? And what we have add 1 comma A2. 1 is the index number. At index location 1, A2 will be added. Because if you remember, we have discussed that in case of linked list, we can very easily add and remove nodes. How new nodes are added? Just by changing the pointer. Okay, just by changing the pointer. So you can see initially at second position F was there. But now we have A2 and the pointer is changed. You can see. Now at first position we have A. At second position we have A2, then F, B, D, E, C and Z. So we have created a linked list which holds these values and each node points to the next node. Is it clear? Yes, you can add more numbers you want. Yes, you can add. But then you have to change the pointer, isn't it? Because we are working with linked list. Yes, if you want, you can add A3 also. It's up to you. Okay. Yes, Miss Fatima, you are writing something? What about the output that I wrote above? Output. Let me see what output you have written. Original contents of 2. Okay. Now let's see. Yes. Original contents of 2 and then, yes, this is absolutely right. So the original contents of 2 will be A, A2. Then what about F? F is missing. In your output, F is missing. Okay. F, then B, D, E, C and Z. Yes. Okay. Yes. Otherwise, your output is absolutely correct. Now, next is we will remove 2 data items. That is F and then 2 dot remove 2. Okay. That means first of all we will remove F. Once F is removed, the pointer location will change. And after that, whatever value which is there at index location 2, it will be removed. Okay, and then we have system.out.println contents of 2 after deletion. So can you tell me what will be the output here? Without F. Okay, F will be removed. But what about this? 2 dot remove 2. What will be the change when you will apply this 2 dot remove 2? Any node has 2. 2 is the index location. Now once F is removed, if you can see this example, once F is removed, there is no change. No, there will be a change because if you see, once F is removed, okay, let's change the color of this node. Okay, once F is removed, what will happen? This node will now point to B. Okay, this node will now point to B. Okay. Now what was the index of F? It was 2, 3. Now once this node is removed, the index of B will become 2. So now B will also be removed. So what will be the output? B will be removed. So what will be the output? See, the output will be A, A2, F and B. Both are removed. Both are removed. So D, E, C and Z. This is the content after deletion. Yes, without F and B. Without F and B. Ms. Amal, are you with me? Is it clear to you? This point is clear to you? Yes, okay, that's good. Ms. Fatima, this point is clear? Clear. Okay, that's good. Now let's move to next portion, that is 2 dot remove first and 2 dot remove last. Now system dot out dot println 2 after deleting first and last. So first element will be deleted and last element will be deleted. So what will be left? A is deleted and Z is deleted. So what is left? Without A and Z. Yes, so the remaining elements are A2, B, E and C. Okay. And now the last block of code. Here you have, see, at index location 2, we will include this string that is changed at index location 2. Okay. And then we will print it. So 2 after change. Now what is the index location 2? This is 0, this is 1 and this is 2. So here we will add change also. So that's why we have A2, D, E changed and then C. Again see this code. See this code. Look, it's clear. Yes, Ms. Amal, it's clear? Yes. So in this example, you have seen that we have created a linked list. We have added some data values in nodes and then we tried to remove some nodes. We have added a new node. Okay. So these are the two operations that we can do very easily in case of linked list because just we have to change the pointer position. So today we have discussed some programming examples based on stacks, queues and linked lists. If you have any query, you may ask. What's the difference between array list? Yes, the difference between array list is, you see, if we broadly classify data structure, okay, there are 3 types of data structure. First one is known as random data structure. Second is known as sequential data structure. And third is known as limited data structure. So if we talk about array list, it is an example of random data structure. Okay. And if we talk about linked list, it is an example of sequential data structure. And when we talk about stacks and queues, it is an example of limited data structure. Now, what's the difference between linked list and array list? In case of array, you have to reserve the space, okay? And you can use only that space only. Yes, there is an index. And you have to suppose you set the size of array to be 5. So if you set the size of array as 5, you cannot enter more than 5 values. You can enter just values having index value from 0 to 4. Okay. Take a simple example. If you want a book, okay, if you want to open a page of a book, you can open any page you want. It's random in nature. Likewise, in case of array, you can access any data value you want. It's random in nature. But in case of linked list, okay, the advantage is you can add any node you want, but you have to access it sequentially because it is an example of sequential data structure. Just like tape, paper roll, okay? If you want to open a paper roll, you have to open it sequentially, like in case of linked list data structure, that you can access each and every node sequentially. Is it clear? Any other query? Okay, no question. Okay, thank you both of you for coming. See you in next face-to-face lecture, inshallah. Till then, take care. Assalamu alaikum.